Hey everybody, this is Larry. This is day 7 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And today we have a loading screen of the problem 1760, minimum limit of balls in a bag. Yeah, let's go. These days, today I'm probably just going to take a quick nap after this because Advent of Code is at midnight, and it's been kind of, honestly, making me really tired. I think as a result of all the marathon training, all this stuff, I haven't been sleeping super well, and doing the problems and the stream, it's been even more tiring. So I don't know. So I'm gonna take a nap after this. It's Friday, yay, and yeah. One more thing I would say is that I'm telling a story on my Instagram. If you really want to check it out, it is Larry somewhere. There's a link on my description. But I've been kind of getting into writing more a little bit as well, and I'll probably need to post stuff on my other channel, but that's another story. But definitely hit me up and let me know what you think about the stories of my writing and stuff, right? Because I'm still trying to get a little bit of practice in. But anyway, yeah, let's take a look at today's problem. We have minimum limit of balls in a bag. Okay, so you have array nums where ith bag contains nums of I of balls. You're given it an integer max operations. Okay. Take any bag of balls and divide it into 2 bags of positive number. Okay, so you just divide it. Your penalty is the max number of balls in a bag. You want to minimize your penalty after the operation. Return the minimum. Oh, excuse me. You want to minimize your maximum number of balls. Okay, so I mean when I think the first thing that I think very often people ask me, how do you know it's a binary search problem? I mean, okay, there are some basics like you do enough problems, you practice enough, you just have that idea, right? I mean, that is what it sounds like. So I don't, like you practice enough, you've seen similar problems, you have the idea. But on a problem that I don't really know yet, honestly, the idea that I do is just guess. And what do I mean by that? I mean that, okay, let's say that I think this one is a binary search problem. Is there a way to, either using greedy or some other idea, to make that function work, whatever the binary thing I'm searching for? In this particular problem, that's really how I thought about it, even though maybe I've solved similar enough problems that I'm like, okay, let me think whether binary search works. And then I'm like, oh, it should work, which is binary search on the answer. And the answer is the maximum number of balls. The idea here is that, well, there are also like maybe one observation. I don't know if it's a full observation, let me know. But you have like 20 balls and you have 3 operations. Then you could take, technically you could do it as a, what is it, like 776, right? Something like that. But, if you want to think of it as a step-by-step, you have 20, you go to 14 and 6. And then you do 7, and then you go to 7, 7, 6, right? Or the other way around. Really doesn't matter, right? Which direction you go, as long as you have 20 balls at the end, right? So yeah. So now this gives us the idea to binary search on the answer, and that's pretty much the idea. Is that each bag you can be greedy in the sense that you keep for each you put as many balls as your limit is, and then that's it. Okay, so let's do it, right? So I always do left and right just because I don't know, left bound and right bound. And what is the left bound is 0? Is that 0? I don't know. Maybe 1. I don't know. Actually, maybe it could be no. Yeah, there is no 0. Technically, I guess maybe it's just 1. And then the right bound is, I'm a little bit lazy, you can figure it out, I just write max of numbers, right? Meaning you have 0 operation, max of your numbers is going to be the answer, right? And this is the way that I always write it because it's easy for me to understand it. Feel free to do your own. Is that when left is equal to right, because that's why I like using inclusive bounds, is because when left is equal to right, then you have a range of 1 number, and that is your answer, right? Okay. So then now we have mid is equal to right? And then now if good of mid, what does good mean? So, people say template, stuff like this, but what does good really mean, right? We can define it as if target is the max number of balls we can do it in let's say fewer or equal to max operations, right? So something like that, right? And there you can go through the list once, right? So then now how many operations does it take? Well, for x and nums, we want to say the max number is target, then you just divide it by target, round up, right? And the way that, if you're uncertain about it during contest or just to yourself or whatever, just play around with real numbers, right? Let's say the number is 10 and your target max number is 3, then you have 3, 3, 3, 1, which is, 10 over 3 is going to be 3 and a third or whatever, so you round up to 4. So same thing, right? So operations, we added by x divided by target, round up, so you can maybe write this way, but to keep it as an integer, you could also write it this way. I'll leave it for the viewers at home to kind of leave it as an exercise to see for you to prove it if you're curious about it. But yeah, but that's pretty much it. So now, what does this mean if it's good? If this condition is satisfied, then what do we want to try? Well, we want to minimize our penalty, so we want to try something smaller. So then we just move the right bound to mid, because then now we're taking the smaller half to try, right? Else, well, mid in the else, then mid cannot be true, so we just do, mid plus 1. The plus 1 is because mid cannot be true, so you move the bound past the last case where it cannot be true, right? Because then now, you can also have done this technically, I guess, infinite loop aside, but you know that mid cannot be the answer, so that's why. And that's pretty much it. This is all I have. This is going to be binary search, and it is very wrong. Did I misunderstood this one? We have to return the... Nine. How did now honestly I'm a little bit confused, but I've been making a lot of silly typos a lot, so hopefully it's just one of those. Okay, so 9, right? So we choose a target. No, I mean, how did I get 8? That x plus target 1. No, I mean, okay. Well, I mean, let's print something. I don't know. Sometimes it is more interesting to learn from other people debugging, but yeah. Oh, that's me being dumb. Okay, that's much better at least. I mean, I was kind of doing it the other way as an illustration for the viewers at home, and then I just forgot to actually change it to integer division. So that's a little bit silly. Okay, so if you have target of 5, you do 2 operations, and that's good, right? 3. Oh, I'm dumb. Okay. Basically, the idea is that this is actually not the number of operations. So, okay. I mean, I kind of went by this too fast because I was focusing on the rounding up. But yeah, if you have 10 divided by 3, for example, or going into, again, using a real world example, there are four groups, but 3 operations, right? So it's this minus 1. There you go. So that that's why these things kind of, you have to be really precise. Number of groups is not equal to number of operations in this case, but I was going a little bit fast. Let's give it a quick submit. Oh, one time error. Hopefully I don't have anything today. Okay, good. 12-day streak, and that's it. That's all I have for this one, I hope. But yeah, what is the complexity, right? So yeah. This one's gonna be O of n because we loop to see every number once, and this one is O of log b, where b is the range of the numbers, say, or O of b if you want b is the number of bits, because that's how binary search works. Yeah, because it divides your search space in half every time, right? And that's all I have for this one. Sorry, my eyes are kind of like I need to take a nap. I'm old. I need my beauty sleep. And that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. If you're doing advent of code, good luck later, and I'll see you later. Bye-bye.